Good morning, good afternoon. Welcome to this new edition of Prediction Guard's webinar series. Today, we're going to talk about self-hosted sovereignty. I'm Katie Bowen. I lead go-to-market here at Prediction Guard, and I'm joined today by Daniel Whitenack, our CEO and founder.
Hi.
And we're going to have an awesome session today. We're going to take you through all the great things we've been working on and building and launching at Prediction Guard and talk about why it's a reflection and evolution of the market and how we're meeting that demand. So let's get started. Dan, how are you doing today?
Doing really good. Excited to chat through things. Obviously, the AI world seems to evolve every few months, and we're evolving with it. So excited to chat through those things. Just so people know, you can please put your questions or comments into the chat part of Zoom or the Q&A panel. You can do either one. We'll be monitoring both. Just put your questions in. We'll have some time at the end after we go through some of the information and demo for questions.
Can't wait to get started. So Dan, tell us a little bit about, where we've been with AI, as a market these last couple years and how you've seen it evolve. I'd love to hear your perspective and how it's all culminated into how what we're doing now at Prediction Guard.
Yeah, that sounds good. So I'll start into some material that I've prepared and a demo here in just a second. But I think even just setting the stage before we do that, if we roll back the clock a little bit with Prediction Guard as a company, coming out of the AI world and many years in that world, a lot of what we were thinking about in those first couple of years of the company was privacy around models, the more, I guess, around like where data is flowing, what data is flowing into what AI assets. And really the market as well was thinking about a kind of model-centric approach, right? Like which model are you using? Which is the best model? Where is that model hosted? And is that model private or is the model training on your data? Those are still not irrelevant questions, but we've advanced quite a bit since then. And I'm going to go ahead and share my screen. And let me pull up here. Um, so just talking through a few kind of shifts that we're seeing in the market right now, one of those being from this model-centric view to what I like to think of as a shift to distributed systems. So, like I say, as before in the world, we were thinking about which model do you have, do you have access to a good model? Do you have a private model? Now we're building AI agents that are actually kind of on top of a distributed agent harness, meaning you might have multiple models under the hood, LLMs, vision models. You may also have MCP servers, connections to APIs. So this is a distributed system of things now that we're dealing with. And so the ecosystem and what you're building on as an AI builder has actually become more fragmented and is distributed in this way. That's created some interesting challenges, and there's been kind of a number of challenges that we've even seen in recent times. One of those kind of being related to supply chain. We saw a bunch of news about Anthropic and how they were identified as a supply chain risk by the U.S. government or the Pentagon. That's one example of how kind of this distributed system of things can be problematic because if you have something like that in your supply chain, of this distributed system, then you potentially have kind of supply chain risk and a need to inventory what you're building your agents on. But also, we see things like the Light LLM hack, which happened recently, which, if you're not familiar, Light LLM is kind of what we would call an API or a AI gateway. It's a thing that kind of combines access to a lot of different AI systems, external usually to your infrastructure. And so there's a hack on the system, which means if you're dependent on these API gateways that are outside of your security boundary of your company, that's just like a big, huge target for people to target because it's external to your company. And part of this has also been exacerbated by people using again things that are more distributed and connected, things like OpenClaw or even Claude Code and some other things like this. So if I was to summarize where our mindset has shifted as a company, we've actually shifted to kind of a number of tenets that really are informed by the impact that we're seeing on AI engineers, platform engineers, software vendors. So AI engineers are creating agents. They're not able to get those into production because of the supply chain vulnerabilities, or security violations that sometimes the security team doesn't even know how to deal with. Platform engineers are being asked to support all of these sorts of connected agents that are built on top of all of this distributed set of things, which is complex and hard to integrate into existing, monitoring, logging, etc. And software vendors who want to integrate AI features into their software are now being asked a bunch of AI-related InfoSec questions, driven by supply chain risk, how they're governing their AI features, which is often kind of blocking release to their end users and preventing, in certain cases, a lot of extra revenue opportunity. So to overcome these barriers, kind of the mindset shift that we're having as a company, which I think is a general mindset shift that you can have as kind of AI operators, is that rather than thinking just about privacy and the flow of data, what we need to be thinking about is control, as a prerequisite to security. So for this distributed set of things, do you have any way to control the access and use of those distributed set of things? So again, a shift from distributed or from models to distributed systems. You want to be thinking about how you can exert your authority and sovereignty over the handshakes between the different things in this system, models, MCP tools, etc. And you want to think about, again, kind of going back to that light LLM hack, you want to be thinking about how you not just outsource the governance of your AI system to something that is external outside of your security boundary, but to something that is internal, embedded into your own environment, into your own infrastructure, where you actually have true control before anything leaves your environment. That, of course, has allowed us to really, that mindset has allowed us to re-envision a lot of our product, the Prediction Guard product, to meet that need. So, driven by those principles, we've actually, in many ways, created a new set of offerings within Prediction Guard, that is focused on these two things: AI systems and how you secure, govern, deploy, and build on top of those secure AI systems. And that's what I'm going to show here in the demo. So the first thing that to emphasize here is the kind of management access of this. Again, AI agents now are built on top of distributed sets of things, models, MCP servers, applications, or frameworks. And so the first thing that we're doing as a product is allowing you to manage these AI systems, meaning actually compose the various components of those things together into a single AI system that you can operate, or multiple AI systems where you can isolate those to different environments or different end users. And integrate models and tools from any vendor. So this is vendor agnostic, tool agnostic. The way that that looks in the product now is actually kind of front and center. You can see these AI systems here in our new, what we call the admin console. And these systems, if I go in here, can have any number of models, right? Which could be private models. So maybe this embedding model that I'm hosting in my own infrastructure on my own hardware, CPU or GPU hardware. It could include models that are managed by us, Prediction Guard, which we have in our infrastructure, or external models like an OpenAI model or an Anthropic model, etc. So here you're actually able to compose all of those vendor agnostic models together, connect through MCP servers into your environment, through a custom MCP configuration or a pre-built MCP server for various systems. And then on top of this system, you have a standardized API that actually allows you then to have common access, unified access to all of these AI tools, including your ability to set your own rate limits, throughput, quota, etc. So the result of this is you can create isolated systems, maybe per customer, per environment. Each of these could have a tailored set of AI components, which are spread across various vendors or MCP tools, and tie all those together into a common AI system with a common OpenAI compatible API on top of it. So that's the first thing that we're doing here is managing these AI systems. The second thing that we want to think about now is now that we have consolidated those AI assets into a single system, that then allows us to have a control plane on top of that AI system within which we enforce governance. Regardless of what AI vendors are under the hood, whether that's AWS Bedrock or Azure OpenAI or a self-hosted model or an air-gapped model and environment, we can actually set up the configuration for the governance of that system in a way that, one, aligns with kind of the best practices and standards out there from NIST, OWASP, et cetera, but also that is able to ship to any of these environments and be enforced regardless of that environment. So in our product now, that's looking like this set of things over here, this security set of things, and primarily this govern piece. Right, so we have governance built in where you can apply configuration from commonly referred to standards or industry best practices, and or you can customize those policies, whether it be for how you handle PII flowing through the system, how you handle prompt injections, et cetera. You can customize those also to your environment. Either blocking things as they flow through the system or logging events out to an audit log for that system. Regarding that audit log, obviously, we don't want to recreate the wheel and recreate all of your security and monitoring infrastructure. We actually want to plug in to that infrastructure. And so you would put these policies in place and then actually come in here and configure a connection to your choice of SIEM or security monitoring infrastructure. Here I've actually got Grafana pulled up for one of our systems, this demo system, and I can actually submit an example prompt injection to this system. So here, ignore previous instructions. And that's going to get blocked due to an organization governance policy. And that organization governance policy was set in this control plane and managed there. But the logs associated with the actual blocking of that event and when it happened and how are now exported to my logging system. So I can actually look at that injection attempt here in my centralized alerting and monitoring platform. Okay. So moving on, we've talked about managing AI systems, so bringing all of those disparate AI assets together, enforcing governance and configuring governance policy on top of that, and the fact that we can export that to commonly or existing InfoSec systems. I also want to talk about how we've thought about deploying these AI systems. So there's one thing. It's one thing to be able to manage an AI system and put all the pieces in place, and then put governance policy on top of that. But the reality is that if you are only doing that, and that is external to your environment, then you're creating, again, this giant vulnerability on your company because you have this external target for both attackers. You have external management of your AI security, and you're offboarding that to a place outside of your security boundary. So we don't want you to actually as prediction guard, we don't want to own that. We want you to own that control plane, manage that governance, and actually plug this into your existing environment. So the way that we've architected this is for you to actually use that admin console to configure your AI system, set the governance policy that fits your environment or the environment of the system, and then actually deploy that control plane within the environment that makes sense for you, whether that be in a cloud VPC on any of the hyperscalers, on premises, air gapped, whatever that needs to be. We have flexibility infrastructure wise. So not only are we vendor agnostic on the AI model side, but we're infrastructure agnostic on the control plane side. So we can ship those into these different environments. A note here is that this doesn't require you to host the models self-hosted, meaning like you don't need a big GPU cluster. But what we want to have you self-host is the control plane elements of each of these systems, such that when your developers are developing an agent, they're not connecting to api.openai.com or Anthropic or even api.predictionguard.com. They're connecting to api.yourcompany.com. That traffic is flowing through your control plane in your environment where your governance is implemented. And that telemetry is going to your monitoring and security stack, not ours. We're not being opinionated about that. That's going to your environment.
So Dan, the composability and the ability to deploy into any infrastructure with that governance harness that you've set as the operator of this control plane seems very unique. It really presents an opportunity to drive governance to the edge, especially in applications with maybe say manufacturing or um, uh, the federal
Yep.
work world. Can you talk a little bit about how that governance is managed at the edge?
Yeah. So when we go into the product and actually create an AI system like I showed here, um, I can create that AI system. And of course, we provide all sorts of custom ways to configure that AI system, including air gap support and custom networking options and that sort of thing. But it can be as easy as creating uh, Katie's system here. Um, that then is created. I can compose the models into that and the MCP servers. I then can configure the governance associated with that system, again, through this governance control plane. And when I then want to make sure that that system is in the environment, the control plane of that system is in the environment that I want it to be in, I can simply get the deployment command for, depending on how I want to deploy that, I can get the deployment command for this system. And again, like you're saying, that system is then all the configuration for the models, the configuration for the governance, the configuration for the monitoring connections, the auditing of that system, all of that is shipped into the environment where it needs to run. Again, air gap, cloud VPC, on premises, however you need to run that. So as opposed to centralizing a big target of all your governance configuration, we're actually letting you own that and letting you control it in your various environments. We've seen MSPs do this for maybe customer one, customer two, customer three, and they're able to create isolated systems for each of those customers with individual configuration for their environment and their governance needs. We've seen, like you say, manufacturing or logistics do this per facility. It could be if it's your company, maybe this is you create one per department or one per geography, or dev prod staging, one for research, one for production. There's all sorts of ways to compose these systems, but the idea is each of these has an isolated single tenant control plane that allows you to control the unique governance and configuration of that system per system or globally. Yeah.
So I guess that kind of begs the question, how are infrastructure engineers doing this today if they didn't have something like Prediction Guard? And, you know, what does
Yeah.
that look like per hyperscaler or per cloud or per situation?
Yeah. Yeah, there's kind of two ways to go about this now. One would be, of course, to try to stitch together hyperscaler specific services that could handle the logging, auditing, security detection, guardrailing, et cetera, pieces of this. The reality is that there aren't enough of those services already to get fully compliant and aligned with something like NIST 601 or OWASP. So you're never going to quite get there with the hyperscaler built-in services, but also you're going to use many, many different services. This would be kind of like saying, oh, I'm going to build a CRM from scratch using a bunch of different hyperscaler services. You would not do that because it would be one, very complicated, and it's there's always already platforms that support that, but you would also have to maintain it over time. So that's kind of a similar argument here. The other way people are, of course, trying this are using open source projects that are stitched together, model servers, guardrailing systems, logging systems, etc. That has the same sort of build versus buy trade-offs that you might think of. And because the AI ecosystem is developing so fast, right? There's a big risk there where you're going to have to potentially re-architect your system over and over to support some of the things that are coming down the um, into the market. Yeah.
Yeah, super helpful. Thanks.
Yeah. So we've talked a little bit about managing those AI systems, so bringing the things and consolidating those together, governing those AI systems, then deploying the control plane plus the governance configuration to the environment that you want to have it operate in. The last thing, of course, that we want to ensure is that you're not just managing governance and infrastructure, but you're actually getting ROI on top of these AI systems. So we want to be very conscious of your ability to get time to, quick time to value, and have that be flexible between code forward development type of things, where maybe you're a software vendor or an internal development team and you want to develop code first, in Python or whatever language you're developing in. We also want to make sure that you have the ability, if needed, to have no code agent development that's tied natively into this governance and system configuration, and the ability to plug into vendor integrations, for example, NetSuite or whatever it might be, or maybe code development platforms like a Cursor or a Claude Code, et cetera. So we've architected the system such that each of these systems that is shipped maybe into your cloud VPC, the control plane of that system has an OpenAI compatible API where you're able to manage those API keys. Because it's OpenAI compatible, that means if your developers are already using LangChain, Llama Index, various frameworks, they can essentially just swap out the base URL that they're using and almost have a zero refactor kind of integration with now your secure sovereign AI system. Similar on the vendor side, some of these vendors have MCP tool integrations that can be registered, like I showed in the product. Others allow you to input your OpenAI compatible API endpoint. So depending on the vendor integration, that's what we're seeing there. And the last thing, which is really exciting, is some of what we're doing with what we're calling Agent Forge, which is this no-code agent building platform that's natively integrated to the Prediction Guard ecosystem and that corresponding governance. So this is what that looks like. You can build all sorts of agents here. Oops, I'm on the staging one. I'll go. I should have been. I should have known that. I should use production, not staging for the demo. Um, so you can go to the agent builder, create a new agent. We actually have a way for you to create this agent using natural language, so you don't even have to configure anything. But there's also the full configurability behind the scenes, which includes kind of custom styling of this agent, connection of knowledge bases, guardrails that you want to put on this agent, etc. But building agents is as simple as asking a question and following some prompts here. And that will actually then configure and apply the configuration for your agent. And I now have this agent. It's been configured via the AI assistant, and I can go ahead and use this. I can publish it to a iframe, a public endpoint. I can share it internally to my org. And the nice thing is that that agent is now plugged into this same governance panel. So your no-code users, maybe it's your HR department, let's say, who's creating an onboarding agent. They can create that onboarding agent in 15 minutes. They can start using it, and if there's malicious input to that agent, if there's bad things coming out of that agent, if there's things that don't fit your governance policy, you'll actually be automatically, that governance policy will be automatically enforced at the agent level, and you'll get feedback into your centralized alerting monitoring system, say Grafana or Splunk or Datadog, with messages that give you the telemetry saying, this API key submitted this malicious input to this agent, which was powered by this one of your models at this time. This is how we handled it, maybe blocked that event. And all of that gets fed back in terms of the observability side and the enforcement at the agent level. Um,
So a lot of
yeah.
the customers and folks we talk to are, kind of kicking off their first agent build or first series of agentic use cases. When we move into this era of multi-agent systems, what are some of the unique security challenges when agents start talking to each other, or external tools like MCP servers?
Yeah, I think that some of the things with MCP servers starting there is making sure that the architecture of your platform has some best practices in place, like proxying those MCP servers, making sure that the right authentication is in place. We're actually, some of that is built into Prediction Guard at the actual product level. Some of it can be enforced and will be enforced at the governance level, like the policy level. As far as the agent side of things, there's a bunch of things that we're building off of, but really driven by kind of the OWASP top 10 for agentic use cases, where we understand, the identity of each agent. Like I say, an agent forge there, we actually have a configuration for each agent. We know what's flowing into what. We also know what knowledge is being pulled. There's things like if you don't have context for a certain answer, a certain action, that should be considered an incident and should be logged. So those are all the things that we're thinking through from the MCP server side to the agent side, identity, and then also the actions of the agent in terms of calling tools, but also accessing knowledge within your environment. Um, So the last thing I want to show, which we're actually going to do a follow-up to this webinar early next week, so you can expect that, and certainly we can answer questions if we don't get them answered here today live. But what we've essentially built and I guess evolved from this era of thinking primarily about giving you private models. We've evolved to, as a company and as a product, Prediction Guard, to this architecture of really supporting AI sovereignty at scale. And what we mean by that, again, is allowing you to have full control of these AI systems that are operating in the environment where you want them to operate, uh, with governance that's enforced in the way you want governance to be enforced, and then allowing for that ROI to be built on top of those systems, either in a code forward or no code manner. So we'll share these slides obviously as well, and try to answer questions about this. But the idea here is you're interacting with that admin console, which I showed, to manage, govern, deploy these AI systems. And then once they're deployed, get that quick time to value either via the API to those AI systems or the Agent Forge no code builder. Um, what we're seeing, I guess, on the back end of that is some pretty significant findings where we are seeing, you know, a reduction in these barriers for these different personas, AI engineers, platform engineers, software vendors, with some pretty significant results. So AI engineers seeing a huge increase in the ability to actually develop secure agents because they don't have to put all this governance and manual guardrailing in place around their agents. They can trust that that's enforced at the control plane level. 90% reduction in system complexity for platform engineers where they're not having to stitch together all of these open source or hyperscaler services and devote labor to maintaining those over time. And then software vendors who are seeing significant increase in actual feature delivery because they can actually answer those InfoSec questionnaires. They're confident with how they're managing the governance of those AI systems, and they are able to actually ship their software in many cases into customer environments that have their own constraints or unique governance considerations. So that's the end of my kind of spiel, Katie. Happy to see if there's any questions from your end or the audience side.
Yeah, absolutely. Thank you for taking us through that. I was listening to the podcast recently, and you had someone on talking about small language models and delivering AI to the edge, which I think is really synonymous with some of the investment we're hearing in robotics this year, over the next 18 to 24 months. Kind of where do you see all this culminating, Dan, as far as the governance control plane side of things? um, how we're going to see AI at the edge, in a bigger way, and really
Yeah.
that, but not without complexity in the traditional sense as well, where we're embedding AI into existing like cloud native applications, things like that.
Yeah, I think that we're kind of moving again from that kind of AI consumer mindset to AI operator mindset. And that also corresponds to maybe there's a variety of terms that are overlapping here, like edge AI, physical AI, embedded AI, federated. There's a lot of terms that are kind of overlapping here, but I think the main idea is that AI will be embedded within the operating environment where where your company is operating. That could be a data center, that's maybe more centralized. It could be, though, more distributed, like manufacturing facilities, workstations in research labs, uh, phones, etc., or like point of sale in retail locations, or heavy edge nodes in larger, retail locations. So I think that's a general trend that we're seeing. And we kind of have that shipping the governance configuration with the AI system into the environment where you need to run. Both gives you control, but it also fits this kind of new model of operation.
Yeah, absolutely. It's all coming together. Hopefully, for some of the folks we've been talking to, faster with an AI control plane that's model and cloud agnostic. Um, awesome. Well, thanks for this. I think we have a lot of other great ideas for webinars coming up specific to um, code assistance and some of the bigger integration points for large ERP systems, things like that, that can be really useful. So stay tuned. If you're watching, we'll send out more information about upcoming webinars. Thanks for joining us.